I had to deal with it every day.
There we go.
I had to deal with it daily. On my computer. Like typing a paper and
Benji, shut up. Because this computer is not the computer I started this year out with. This computer.
Is that the new one or is that the brand new one?
It's the new one, fully restored.
They let you have a new one after you...
what can you do? What did you try?
I know people in very high places.
I'm
going to move this behind your thought.
I hate you more than I hate myself.
I get that a lot.
From me.
It doesn't change the fact that I get it a lot. As long as he doesn't make us write any answers on the board, I'm good. You're telling me.
Yeah, that's what you're saying. Alright, we ready?
No.
Are we ever ready?
Okay, guys.
5 minutes.
How many students does it take? Alright, ready? Okay, number 1 is E. Number 2 is 3. Number 3 is negative 3h bar, negative 2h bar, negative h bar, 0, h bar, 2, h bar, 3, h bar.
That's not funny.
Negative 3 to 3, what time, all times h bar. Right?
What?
It's like negative 3, negative 2, negative 1, 0, 1, 2, 3, but all times h, each one's times h bar, right? You have to have the h bar technically, because I did ask for body of angular momentum, so the units need to be right, so it has to have an h bar. So it's, you can't just give me the values of n, you have to multiply by h bar.
Like this.
Forget, not a huge deal.
What about 0?
Okay, actually 3, 4, and 5 all have the same answer. Number 6 is 2 root 3 h bar. If you got 12 h bar squared, that's reasonable enough, but I asked for the angular momentum, so you have to take the square root. Okay, number 7 is E. Number 8 is C. Number 9, E. Number 10, C. Number 11, E. Number 12 is negative 2h bar, negative h bar, 0, h bar, 2h bar. So, same thing except from negative 2 to 2. Number 3 is 6h bar squared. 13 is 6h bar squared. Number 14 is 5 halves. Number 15 is root 35 over 2 h bar.
What was number 14?
Number 14 is 5 halves.
15?
15 is root 35 over 2 h bar. Again, if you got 35 over 4 h bar squared, you have to take the square root. It's not a huge deal, but just something to remember. Number 16 is A, C, and D. No, h bar is outside. Yeah. And the 2 also is outside. So it's root 35, then over 2 h bar. So only the 35 is in the square root. Okay, number 17 is negative h bar over 2 or h bar over 2. Okay. So, the questions? Or do we just not do it?
That one.
All right.
I had an essay.
Not my business, but you did, the quiz for this unit is going to be on Thursday, not Thanksgiving. After that,
Two hours.
we have a night test on Thanksgiving. So,
Wait, can we all eat turkey?
while we take the test together. The best thing. You have so much to be thankful for.
I'm thankful for
You can test it. What a great idea.
You would have had those kinds of thoughts anyway.
Well, you know what? How about I'll just leave
That's
that for the
the
moment.
ModPhys is just a
Take
catalyst
questions
for
another
them.
time.
That's true.
At such a time when people actually have them. I figured, you know, it'd be good to do it now because you didn't have anything else to do today, unlike Monday where you do have something due, right? But whatever, yeah? Sure. Oh my goodness, so many actual questions, that's amazing.
What is this over?
Okay, so, 16 is actually quite an important one. It's a conceptual question about quantum mechanics, and you know how I like conceptual questions. So the argument is, well, the electron spin is 1/2, right? What's 1/2? And the possible components you can measure in the z direction are plus h bar over 2 minus h bar over 2, right? And since the total spin is 1/2, then that means it's either all, when you measure it, it's all in the z direction, right? Wrong. Okay, but that's the argument here. So if it's all in the z direction, that means you do know the other components. They'd be 0, right? So then you would know the other components at the same time, right? So that is incorrect. And one reason you can say so is that there's a few things you can say. First of all, you can just say what part A says, which is when you know one thing, you cannot know the other ones, right? So that already violates it. You say, no, they're definitely 0. And you're like, no, that's not true. Furthermore, what does it mean for the x component to be 0? There's only 2 possible values. And that's h bar over 2 or negative h bar over 2 whenever you make a measurement, right? Those are the only possible values for x. And maybe the big thing is the total angular momentum I need to get some more markers. The total angular momentum, let's see if this works any better, it's a little better, is L sub s equals 1/2, right? So if we want to calculate what, I guess for spin you'd be calling s squared, right? If you want to calculate that, it's L sub s times L sub s plus 1 times h bar squared. And that's 1/2 times 1/2 plus 1. So that's 1/2 times 1/2 plus 1. 3/2, good. So that gives you 3/4 h bar squared. Or if you want to do it as the magnitude, find the magnitude of s, therefore, would be the square root of that, which is root 3 over 2 h bar. So the total angular momentum is not 1/2. The total angular momentum uses an L equals 1/2. But if you calculate what that actually corresponds to, it comes out to root 3 over 2 h bar, which is bigger or smaller than 1/2? Bigger, as it better be, right? So just because, so you measure h bar over 2 in the z direction, that is not all of the angular momentum. There is some remaining angular momentum that has to be somewhere in the other components, but of course you can never know that. Yeah?
So
C, no, they're giving 2 different arguments. C is saying that the x, you can never say the x component is 0. So whenever you measure the x component, you know it's h bar over 2 or negative h bar over 2. Those are the only options, right? D is saying what I just said. The total angular momentum is not 1/2. The total angular momentum is actually root 3 over 2.
Mm-hmm.
Yeah.
For A, is there any significance to the fact that like spin and angular momentum are
Not really. This is not a question about orbital momentum. This is really just a question of spin. It's about one particle, not any orbiting going on. Good. Any other questions about this? Well, why don't you go generate some questions? It's almost important. I know it's long. It's almost important. Yes, Mike.
So this question not necessarily about the homework, but it's about the spin and orbit. So we know from your experiment that like the spin affects the orbit in which you do it. So how does this work with particles? Like you were holding the wheel. If the wheel is representing the spin.
No, the wheel. Right. Okay. That's only if it changes. Right. Roughly speaking, how do you measure spin? Well, you can only measure spin, or any angular momentum. You measure it by coupling it to some other system and then changing it.
Mm-hmm.
And then you see how the angular momentum changes, and that lets you know what it was beforehand. But that's a change in the angular momentum, right? So your measurement will always cause a change in the original particle, and that's how it can do it without violating any conservation laws. It has to do with how you measure. Typically, though, the way you measure is you couple to a magnetic field, so while it does suck up the angular momentum, it doesn't do it in any way that you can notice particularly. We'll talk about that later. Okay. Yes? I'd love to. This makes me happy. Okay. I said if I could measure the spin, I could get 6 different answers, right? To figure out how that could work, you can do it by a little bit of guess and check, if nothing else. Like, for example, let's try L sub S equals. Pick a number.
5.
2. For example. 2 is easier. Then what are the possible values of F sub S? Oh, well, -2, -1, 0, 1, 2. How many is that? Well, that's 5 answers. Okay. Furthermore, you can see pretty quickly that for any integer, you would have a 0 in there, plus the other ones, which means it's going to be an odd number of answers. So if you want 6, that means you're going to need to do a what? A half integer, right? So it's like, well, this gives me 5. I want 6, so I probably just need a little bit bigger. So you try 2.5 or 5 halves, right? And then your N sub S is -5 halves, -3 halves, -1 half, 1 half, 3 halves, 5 halves. And 1, 2, 3, 4, 5, 6. Good, so that fits. So that's the L sub S value that we're expecting.
When we're doing our homework, can we just write plus and minus 1 half? Plus
Oh,
and minus
totally,
1
yeah,
half?
yeah.
We don't have to write all of that.
Yeah, it's not worth it. Yeah, absolutely.
That was like number 4.
Yeah, I know. I didn't answer your question. I was just getting there. Okay. So now the question is, what's the total spin angular momentum? I wasn't actually ignoring you. The total spin angular momentum then is, well, the total spin angular momentum squared is S squared, right? So that would be using that same equation, 5 halves times 5 halves plus 1, which is 7 halves. Please make sure you are able to add fractions. It's not supposed to be the hard part, but I discovered. All right, so and that gives you 35 over 4 h bar squared. That is the total angular momentum squared. Because I asked for the magnitude of the total angular momentum, you take the square root of that, which would be root 35 over 2 h bar.
Nice.
Okay. Right. This must be, in fact, an irrational number. No big deal. The total angular momentum squared comes out as an integer, or that weird thing that's not the sort of fourth integer thing. It's not an integer. Yeah. What it is. Number 11. I asked you, yeah, you can see the setup. It's very important. That series that ends with number 11, which is like 7 through 11 or something like that, right? It's very important for understanding it. You measure Lx, you measure Ly, you measure Lz, and then I ask you, what's Lx squared plus Ly squared plus Lz squared? Well, right, but you cannot just take the previous answers and then add them up. Why not? Right, the measurement of LZ changes the measurement of LY and LX, right? So you cannot just take those 3 numbers and end up, but knowing one number means you don't know the other 2 numbers, right? So there's only one way to calculate L squared, and that is to know
The total angle.
well, yes, I mean, that's what it is. So what would you have to know to calculate L squared? What do we use? It was a quantum number.
Oh.
L, right, little l, right, the quantum number is how we calculate L squared. So that's the only way to know is with the quantum number L squared. Quantum number little l is the only way to calculate L squared, right? Then you can just do L squared equals L times L plus 1, h bar squared, right? That's the only way to actually calculate L squared. You cannot do it from components because you never know all 3 components. You only know one of them, right? So to do this, we would need to know what L is. Unfortunately, the problem does not tell us what L is, nor does it give us enough information to figure out what L is. It tells us some different values of M, which tells you sort of L has to be at least this big, right? Mm-hmm. So L has to be at least, I think there's a 6 in there, right? Is there a 6 something in there? Yeah, there's a number 6, so L has to be at least 6. But there's nothing that says L couldn't be 10, right? Or 15 or something, right? Then the M's would still be valid. M just has to be less than L, right? Less than or equal to L. So, so because of that, you don't know what L is, and this is the only way to calculate L squared. So the answer is I don't know.
Could you write it as an inequality?
It says, the number 8 says, what is a possible value of the total angular momentum? And only one of those is possible, but other values for number 8, but other values that are not listed are also possible. So that's why. Yes, Mike?
Could you solve that as an inequality, and then...
You could, of course, put a limit on L, but basically, it's going to be L is greater than or equal to 6, right? Which means you can convert it to here, but that doesn't really answer the question, though it does put a restriction on it. Okay, well, should you perchance, for some reason, because you were dancing all night or whatever, should you have not figured out, done the homework, you should do it. Okay? I know there's a lot going on, I understand, I'm not giving you blame, I'm just saying it needs to get done, it's important. Okay? This homework assignment in particular, I made it a double so that you would have more practice. Okay? Because I think that's important. So, so this is basically all you're going to get for angular momentum. And so you need the practice. Yes, sir?
Where would you test over? Just this?
The test will have this plus quantum statistics, which we'll cover next week.
E.
Hi.
Quantum statistics, right? I know your two favorite words in the universe. Together.
What's an statistics?
I hate statistics. It's so far weird. I hate quantum.
You don't know whether it's going to teach you or all right.
Then they are either significant or insignificant. Never change it.
Who would have thought?
Okay. I want to give you the time to work. You guys need to work on some stuff with your detectors. I have posted a new visualizer and a new format that is like a universal format that allows you to put in anything and anywhere, I think, hopefully. It should do that. It worked on my practice one. The format of it, I think, is straightforward enough. What I did was, here's the one thing that's important. Use the Excel spreadsheet, at least to lay things out, because it gives you drop-downs. The drop-downs make sure you won't misspell anything or anything like that, right? And then you can always just fill down for what you need. You can look what's in there. I think the columns are a lot clearer. There are columns that say things like field strength and resolution and stuff like that. The size rules, like the way to determine position and size and shape and stuff like that, none of that part has changed. It's sort of the right-hand side. The right-hand side is where you determine what the type is and stuff. Is a little bit different from the previous ones. But you should be able to do some copy and paste with adjustment to get it in the right way. But if you do that, it should all be set up. For silicon and muons, there's a call for segmentation, okay, which is where you split it up into different things. For silicon and muons, you should just click on. You should just do auto as your one, which is what you've basically been doing all along. And for the calorimeter, you should be entering it in, and it lets you segment in either eta or theta. Eta is probably the default. What I have in there is I have it all set up. The default detectors I did are all set up in there, so you can see what it looks like. It's not a big change. It should work. The main thing is don't leave anything blank. Put in zeros if you don't need it. So a lot of times, it asks what's the resolution of a solenoid, and that doesn't make any sense. So just put a 0, right? So don't leave any column blank. It'll screw things up. Put in zeros instead. Does that make sense? Okay. Yeah. Monday. Yes. Yes. This should not be much to do. All you have to do is readjust your detectors, which means you need to talk to each other. Do you guys know who the other three groups?
No.
No.
The other muon group is
Gabe, Leon.
Yeah, Gabe, the space people. Well, I'm not space anymore because that's the accelerator sets that, right? Yeah, Gabe, that group, Gabe, Leon.
The space one?
Leon. Oh, was it Leon in that group?
Yeah.
Gabe, Vincent, Leon, and Jenny. That's right. Anyway, so that's great. They're the muons anyway. They're outside, so you can basically plan most of it. The only question is budget, right? So you can ask them about budget, but you can plan the size of the inside, to a good degree without that, right? Yes, but it needs to be Monday in class because you got to get the slides done too. I'm sorry for the time rush here. When is Thanksgiving? It's too early. If it were a week later, then it would be a lot easier. But anyway, that's how things are. Okay, but what? No, it actually doesn't mean Christmas starts. It's at the same time it always is. We'll explain it sometime.
By the way, Dr. John, did you spell my name correctly on the ModPhys project name.
I spelled it correctly or incorrectly?
Incorrectly.
Oh, how do you spell it?
BENJY.
Oh, how do you spell it?
BEN space G. My name's Benjamin Goodrich. Last initial G. Why do I have to explain that? Part of name Benji.
We call you Benji.
I know that.
You said, but like if you said like your name was, you're like my name is Robert, but I go by Bob, and I put B-O-B, I think I'd be reason to be like, no, it's actually spelled B-O-B-B, and I'd be like, oh, but it's not something you can expect me to know. Right? Now I know, and I can fix it. All right, good work.
No, but the thing is that like there's like 5 people that get it instantly. It was the first like 5 people that get to, and then everybody else is like, oh, that makes sense. And I'm like,
Benji.
it's so
You
frustrating.
can't say your name is Benji and then expect people not to type it in the way it says.
BEN space G. That's so unreasonable.
That's like me saying, hi, my name is Bob.
It wouldn't be original unless there wasn't already BNGJ.
Alright, Matt. How are you today?
What's your last name, Matt?
Coach. K-O-T.
Oh, we get Nolan too.
Wow.
I just deleted you. Don't worry about it.
What?
Gabe, we need Gabe in there.
I don't have anyone's contact info.
I do.
I'm not.
Well, that's
Why do you
Why not?
Exactly.
He looks real like
You know, you can connect to the ModPhys through.
You know, IMSA doesn't.
okay, guys. I sent you guys a messenger.
That's not inaccurate.
The inner radius is the question. Oh, and also the diameter.
Hi, hello, I don't want to be alive.
Hi, hello, I'm deaf.
我想死了，为什么在
If
这？
you look on Messenger, you'll have it on the screen saving you guys too.
I'm gonna add some people. Did you just name this the failure?
We sound like a band.
Rename this group.
No, don't. Hey, we're the failures, and we're just gonna keep failing around.
That's all those other things going most important is keep it going to our side.
Okay. Add people.
Okay. First things first. What shape do we want You guys are you guys sure to do shapes?
We can't do this yet without them.
Technically we have 2 groups here, so
I know
all
there's
sign on
here,
speed
right?
and we could like
I'm not dumb.
Well, here's the thing. It's based off of their accelerator.
no, it's based off their
But its
accelerator.
location is much more accessible.
No. Wait, whose accelerator are we on? Yours?
Yeah.
Oh, what's your
It
accelerator?
doesn't matter. Oh my god. It doesn't matter.
roller coaster spiral.
Oh, that one.
That was a cool one.
Wait, who's our other partner?
We were going to do that.
Do you
but
not
we were
just
like,
remember him talking about it?
The Miwa.
large
Oh, they're the muon detector. I was thinking they were the
they're-
part of
No, we're not.
You're the tracking
We're the
detector.
tracker.
We're the calorimeter.
Calorimeter.
And then the group from the other class
Is the
is
muon.
the Miwa detector.
That's so sucky. They had, no offense, my dudes, but they had one in space.
But they what?
No idea.
And it cost less.
Are you guys colliding gold particles?
No.
Yes, because they didn't have to build the radiation stuff for the
Oh my
muon.
gosh, the people who reached.
Body gold ions is the
And it costs. Thank you.
Wait, something doesn't sound right.
Who else do we not have?
How big is it?
We don't have Jenny.
I don't know who that is.
If you look on the group, you'll see that. If you look on Messenger, you'll see that I opened up a Messenger group.
But Briella didn't open the
我想死了。
Well, rip Briella. Sorry.
I only have it listed as Micah and Sabian as on the Messenger group at the moment.
Huh?
That's because they're using. This is how miscommunications happen, guys.
Do you want to be added to the group? What's your last name?
MEA.
Okay, I already found you. Wait, why didn't this work? What happened? Oh no, don't do that. I broke it.
Who else is the other person?
No, wait, no, I didn't.
Jenny, Vincent, and
Ha, take that.
Leon.
I need to
Stupid
figure out which
thing.
Jenny it
Dave we
is.
have.
There we go. No, wait, I lied.
P-E-T.
There we go.
Jenny is this.
Like J-E-N-I-P-E-T.
It says J-E.
P-E-T-R.
N-Y.
Yay!
Yeah.
Okay, I'm gonna add her.
Dr. Dong was spelled the other name?
Excuse me?
Is it J-E-N-I? Is it J-E-N-I?
Yeah, Jenny spelled it J.
You spelled it J-E-N-N-Y.
I did. Oh, really? I actually knew that one.
Huxiang Poland.
And Vincent McGigan. Okay, who's the other person in their group?
Leon.
Leon.
Is Leon Fritz?
Leon.
This is Leon Lee.
Okay.
All right, everybody's in.
Okay.
Oh.
I don't know who
An
to
accelerator in space.
I don't know who to
So
Chill.
you guys aren't in space anymore.
Oh.
How about Justin, you have detectors in space?
Okay.
I'm trying to remember.
Honestly.
And it costs less?
Yes, it costs less.
How
I
much
think it was
was it?
because they're, well, they don't pay excavation costs.
Yeah.
They do have to pay a lifting cost per kilogram. So calorimeter is very expensive, but the other stuff's pretty cheap.
Yes. Okay. First of all, we have to know some information. How how big is the accelerator beam pipe that you guys are using? It's first, probably.
I'm uploading the spreadsheet right now.
Wonderful.
Wait, should I add everybody to the Google Drive? Okay, hack.
Okay, let's look at it.
Hack and hack? Okay, wait.
No. It's in the. It's not in
I
the
know,
drive.
but I should add people to the Google Drive so we can all have all of our documents all together and everything can be not as horrible. Kind
It's
of.
not horrible anyway. Okay, so we have one linear. Wait, do you guys only have one accelerator?
Well, so